Alright, another draft science video, and I think we got the final big piece here. Um, it's kind of a, I had been there and played with it, but not really thought about it deeply enough, and but you know, it's the answer, I believe, to one of the little problems. So I was thinking on the subject of gravity, and what's causing. Uh, the problem I had is that we have these two elements of identity in the universe, this polarization. So we could say it was blue and we could say it was green, just to use two colors. Hopefully they have some contrast. And the problem was I can make that work for electrons and protons in terms of the blue would affect the greens and the green would affect the blues. Now the problem is when you turn this into gravity, you're going to have yes, the blues will affect the greens and the greens will affect the blues won't affect the greens won't affect the blues, but you're not really going to get, I was having a problem coming up with a mechanism that would allow that mixture to create gravity between two objects, because it would end up balanced. There would be just as much green getting blocked as blue and vice versa, and it just didn't make, the mechanism just didn't have any energy. Um, you know, wasn't it seemed to be lacking something. I mean, I could get the idea of, all right, so let's just say we have the force coming in this way, and it's a mixed force. So it's going to affect both protons and electrons. And, I could get the idea that force would leave going this way, and that would mean there's less force this way. But it still begged the question that whatever movement, this acceleration this has, it eventually the force is returned. It's only a delay. It's not a consumption of the actual arrows. So it wouldn't be consuming them, it was just changing them, and so they'd still be there to be hit perpendicularly and all that stuff. So it really wasn't an answer to the problem, a good enough answer. So anyway, this over here is the solution. So protons and electrons, let's see if there's a way to draw this, are really, there's probably lots of ways to represent it, but what happens is that, I talked before about that matter does behave different. The forces don't interact with each other in empty space, and yet they do interact when they hit matter. And the thing with electrons and protons is that the matter is essentially compressed, the quanta inside. So where the quanta would have a normal amount in space or distance between them, in electrons and protons they're compressed. And so what happens is when they're gaining acceleration, so let's say we have an electron here and it's going to gain acceleration in this direction, what it's going to do is consume into the compression. It's going to take in a couple of extra little quanta in this direction, and it's releasing them in this other directions, the perpendicular. And so when that happens, it's compressing the normal field here. So the normal field would look like this, and so it adds compression to that, and so that would happen in other directions also. And what's happening out here, so this is the new electron as it's compressed. It adds compression in this direction, it releases compression in this direction, and what happens is it's releasing expansion in this direction. So in this direction there's a wider gap than normal. So this gap gets wider, this gap gets narrower, and so it's just releasing compression in the different directions as it gains acceleration. So as it gains acceleration in a direction, that's really adding compression. And when it and it releases expansion, or an absence of volume in the other direction. So it's really just it now just becomes a volume equation, and it makes it so much easier to understand that what's happening in gravity is that as you accelerate this, and this is accelerating towards this, what they're doing is they're adding compression in this direction towards each other. So that means they're absorbing arrows that are coming in from this direction, and they're compressing those into the matter, so to speak. They're adding them into the matter. They're being consumed in a real sense. And what ends up being released here is an expansion, a lack of density. So there's low volume here, normal volume here. And this volume is increased, and it releases compression in the perpendiculars. So there should be a real effect that this is one of those testable things, that when an object is accelerating towards Earth, it should be releasing some energy, some compression, some extra volume of quanta perpendicularly. And the problem is you can't see it though when it's mixed polarization. See, that's the catch. So when it happens with mixed polarization, it's as noisy as regular gravity, and we don't have detectors that can detect that. See, an electron can only detect the blue stuff, as pointed out before. Two green arrows hitting each other just ends up being green arrow out and green arrow out, and you can't tell if it's a reflection or whether they went right through each other. Impossible to tell. And it's only when you have the polarization thing, where you have a difference, that you can see the difference in the outcome. Electrons can only be affected by blue energy, and because the compression is going to be released from a big object in a mixture, it won't be as easily detected by objects that can only detect one form of the energy, specific forms of the energy. Let me put it that way. Specific would be maybe a better word. But anyway, so this is just like I said, this is just because it adds this idea of volume. It's kind of the key to the whole thing, is this volume word here. And so it just makes it a volume equation. You're condensing, the bits in here in acceleration in this direction, and then to do that you release bits in the perpendicular directions for and in matter you're going to be releasing it both in the protons and the electrons, and so it's going to be mixed polarization, so you won't detect it as magnetism or anything like that. It'll just be detected as a kind of gravity. And it's only proportional. I mean, it's another these it's only proportional to the gravity at that location. So that's the trick, is the actual gravity for something of low mass would be so tiny that it'd be very hard to detect when the Earth, let's say, is emitting it, or a human being. The amount of our extra velocity is so tiny by comparison to the speed of light that you really can't detect the amount of energy we're releasing. It's so slight. It's such a slight amount of force that actually moves things in terms of a difference that's detectable. What else do I have to add? This might be the shortest video ever, because I just wanted to basically say, I mean, this just gives it just makes it so easy to just make it. It's just a volume equation again. It's as obvious as the idea of the school of fish, and the idea that if when they're random and they're not moving, moving just means that some of the ones going this way or this way or this way end up going this way, and you let go the fish going the wrong way, and it's just that obvious. And that's what acceleration is that transition. And yeah, so this kind of solves the acceleration question of how that's an absorption of force. So it kind of explains how it's a true absorption of quanta in terms of the density change. So you end up with a higher density in a direction and a lower density. Obviously, if there's 10 going in and 2 are compressed into the matter, then there's 2 less coming out, and that's what's felt as the uneven pressure in gravity. So yeah, so I think I'll leave it at that until I do a overview kind of video. I guess I could read some comments, I suppose. Yeah, I'll save that for a comment video. I don't want to spoil these drawing videos with comments. Commenters are rather rude and nasty. Mostly are irrelevant and crazy. So anyway, so yeah, so you just have quanta moving the speed of light. I mean, the universe field, the fundamental field is just these little bits moving the speed of light in random directions. They travel in a straight line, and they don't interact with each other at all in empty space. And they only interact when they hit compressed quanta inside protons, electrons, and probably neutrons. And that's the only time they can be converted into compression or be essentially diverted in their direction through the process of the function of the compression of the matter. What causes compression? Well, that'll be it's probably not terribly relevant to the truth of the theory, but I mean, it would be an interesting thing to try to figure out. And whether the compression is always permanent. But really, that's the difference, is the difference between matter and the empty space is just the density of the quanta. They're stuck together essentially inside the matter, and they're not stuck outside. And when you convert them by having more in one direction and getting rid of the ones in the other direction, you create compression in the direction you're released and expansion in the other direction, and that expansion goes forever theoretically in a straight line, and that compression likewise. And that's why a photon still has the same energy even after it travels 7 billion light years across the universe. It's still exactly what it is, which is a compressed hunk of quanta at a frequency. Yeah, and so I don't think there's anything else to add to this. But anyway, important step. Yeah. I'm just trying to do the summation of what, how simple this is. So there's just, the universe is just, the matter is compressed, the quanta is just stuff moving at the speed of light, and it's just about how much separation there is between the quanta, that is the difference between matter and empty space. And yeah, it's just the two polarizations, the condensing of one polarization in the proton and the condensing of the other polarization in the electron. And that's the simple universe that has created everything we know of and such. So anyway, enough of a video. Thank you very much. Till next time and such again.